Hello everyone, welcome to yet another video, and in this one we are talking about another design pattern. The name of the design pattern we are talking here is Evaluator-Optimizer design pattern, and from the diagram it is pretty clear what it does. So basically when a user gives any input to the large language model, the model does the generation task, and after that we don't send the generated output from the model directly to the user, but here we have an evaluator in place. The job of the evaluator is to evaluate the response of the large language model. So suppose if we have given a task to the model and the model does that task and return the response, then there is an evaluator in place which evaluates the task, right? Evaluates the task on some benchmarks, right? Those benchmarks can be provided by us as the developer of the workflow, and if the output produced by the generator node passes all the benchmarks provided by the developer, then the evaluator can pass the response or the output and it can be returned back or provided back to the user. If it doesn't pass all the benchmarks, or if it is not up to the mark, then the evaluator can reject the output and it can send back the control flow to the generator along with a feedback, maybe that hey, your generation or whatever output you produced for a particular task doesn't live up to the expectation or doesn't passes all the benchmark test. So please, I have rejected it currently, and please try to generate or perform this task again. And then this loop goes on and the generator does the task again, maybe this time with some feedbacks incorporated coming from the evaluator, and after that the generator tries to generate the output again, and this goes on until the evaluator passes the output and then it is sent back to the user. So this is what we are trying to discuss in the video. So now let's take a look at the definition, and this is how the introduction or the definition looks like. So let me zoom it up here. Yep. So the introduction says, in Evaluator-Optimizer workflows, one large language model calls create a response and other evaluates the response, as we mentioned in the introduction before. And if the evaluator or a human in the loop determines that the response needs refinement, the feedback is provided and the response is recreated. So as we mentioned, if the evaluator thinks that this particular response needs refinement or it doesn't pass all the benchmark checks, then the evaluator can provide feedback to the large language model and the generator can try to generate the response again, or basically try to recreate the response again. And this loop continues till an acceptable response is generated or till the evaluator accepts the response generated by the generator node. This is how the design looks like. Now, one important thing I would like to mention is the evaluator node. In the evaluator node, there can be two kinds of evaluator. One is the standard large language model. So what you can do is that you can have a large language model as an evaluator, which will be judging the response of the generator, or else you can also have human in the loop. So maybe you can interrupt in between and decide whether the response or the output generated by the generator node live up to the expectation or not. So it can be two, like there can be two people, or basically there can be two types of generation nodes. One can be large language model and another can be a human, right? And that's what we would like to talk about when we do the code walkthrough. When we'll actually build this workflow from scratch, we'll probably look at the two flavors of this workflow implementation. The first one where the evaluator node will be a large language model node, and the second one where the evaluator node will be a human in the loop. So basically we're gonna interrupt the workflow and we're gonna decide whether the output produced by the generator node passes the predefined checks or passes or lives up to the expectation or not, right? So basically we are assessing the quality of the generator node. Okay, so in Evaluator-Optimizer workflows, one LLM call creates a response and other evaluates that response. And if the evaluator or a human in the loop determines the response needs refinement, feedback is provided and the response is recreated. So that is the same thing which we discussed earlier. This is how the current workflow which we are building in this video will look like. We'll do a detailed code walkthrough of it as well. So the workflow will start and we'll give the control flow to the LLM call generator, which will basically generate an output, and then we will have an LLM call evaluator. So initially for the first flavor we'll have LLM call evaluator. After that we're gonna replace this particular piece with a human in the loop node. So LLM call evaluator will gonna evaluate the output produced by the generator node, and it can reject with a feedback, or it can accept and pass it to the end node. If the evaluator accepts the response returned by the generator, it can pass the flow to the end node, and the workflow will end and the output will be provided to the user. If the evaluator rejects, or if the evaluator thinks that the output is not up to the mark, then it can reject this particular output with a feedback, which is sent back to the LLM call generator, and the generator will try to generate again by keeping this particular feedback in the mind, right? And it will gonna try to do this process again, and this flow will continue until the evaluator accept the output of the generator node. Having said that, let's move on to the code walkthrough. Okay, so now let's start the code walkthrough, and I am in my AI Engineer 101 playlist. So if you're aware of this playlist, what we particularly used to do is that we pick up one of the interesting concepts or a POC, and we try to build it from scratch, and we try to understand it, right? So here we are doing the POC or the code walkthrough for Evaluator-Optimizer design pattern. So this is how the agent looks like. I'll just gonna collapse this, and let's do the code walkthrough from the start. So initially what we have are some open source libraries which we're gonna import, right? Once we have imported this, we will gonna define the state of the graph, right? And if you have watched my previous videos, we have built a lot of workflow using LangGraph, and the main concept of the LangGraph includes nodes and edges, and also the shared state. So if we are building a graph, we need to define the state of the graph, meaning how the information will be passed between nodes, what the structure of that information will look like, or what the structure of that object will look like, which will be passed from one node to another. So this is how the state looks like. What my workflow will do is that it will gonna try to write a joke, right? It will try to create or write a joke on a particular topic. So we will gonna give a topic to our workflow, and the workflow will come up with a joke on that topic, right? And then we'll have an evaluator node which will gonna assess whether that joke is funny or not. If the joke is funny, then we're gonna pass it and we're gonna return it to the user. If the joke is not funny, then we're gonna send the flow back to the model saying that, hey, this joke is not funny, create another one. And this process will continue until we get a good funny joke, right? So now the state has the joke which will be produced by the generator node, the topic which will be provided by us as a user, feedback which will be written by the evaluator node if necessary, funny or not, this will also be written by the evaluator node stating whether the joke is funny or not. Then we have a feedback state. Now this holds the feedback returned by the evaluator node. This has two things in mind. First is the grade and another is the feedback. So this is a structured output which will provide to the large language model incorporated in the evaluator node, and that will gonna instruct the model to produce output in this format. So the large language model present in the evaluator node will be bound to produce the output in this format, where it will have a grade which will be a literal saying it can either be funny or not funny. The description is decide if a joke is funny or not. So we are educating the model that, hey, given the joke, let me know the grade. It should be either funny or not funny, and this is the description. So you need to decide whether it's funny or not. Then there is a feedback. So it's a string basically, and if the joke is not funny, provide the feedback on how to improve it. So basically, if the joke is not funny, then you can provide a feedback which will be sent back to the generator node. That's how this design pattern is all about, right? So I'm gonna quickly initialize this. After that, the model which we are using for this workflow is GPT-4o mini, and we're gonna quickly build this. We build the evaluator large language model, and we build this by binding the LLM with the structured output, and the structured output is the feedback which we described here. So basically what will happen is that this evaluator model is bound to produce output in this format. So we can run this one. After that, we have the nodes which should be there in the workflow. First is the generator node, which will be generating a joke or producing a joke for us. The prompt is very simple. Write a joke about the topic which is provided by the user. So it goes into the shared state and we pull the topic here, but take into account the feedback. So if there is any feedback provided by the evaluator node, it will be provided here. Initially, there will be no feedback, so this will be empty. After that, this will gonna return a joke, right? So if there is a feedback, then this portion will be triggered. If there is no feedback initially, then there will be a simple prompt saying write a joke about this topic, right? And after that, this joke, the content of the message will be returned in the shared state. So we expect that this content will be a joke. So we'll put that in the shared state against the joke key, right? So this is the generator node. Now we have a human evaluator. Now this is the second flavor of the workflow, but I'll still go ahead and I'll explain the node here. It's a very simple node saying human evaluates the joke. So if you have gone through my one of the previous videos in the series which talks about human in the loop, you can find it in the playlist where I've explained how you can interrupt your workflow. So I'll not go in detail about it, but what it does is that it basically interrupts the workflow and it will ask us to give a response of whether the joke is funny or not. So is the joke funny? Reply with funny or not funny. So since this is a human evaluator node, we as a human will be responsible for assessing whether this is funny or not. So if I think that this joke is funny, I can reply with funny and the workflow will end. If I think that the joke is not funny, I can reply with not funny and this will be passed back to the generator node saying that, hey, this is not funny, try to come up with another joke. Then we have an LLM called evaluator. Now this is the first flavor. So this is a human evaluator, which is the second flavor. LLM call evaluator is the first flavor. So LLM call evaluator has a simple large language model which evaluates the joke. So here the human evaluated the joke and here the large language model will evaluate the joke. So we have an evaluator. The evaluator model we have already bind here with the structured output of feedback. So it is bound to return the feedback or return the output in the feedback structure. We tell the model that grade the joke and we also provide the joke generated by the generator node, and then the model returns the grade. Now it has two things, the grade and the feedback as mentioned in the feedback state, right? And now we can put it in the shared state. So funny or not, we put the grade here, and feedback we put the feedback provided by the evaluator node here. Very similar. Here as well we provided the same thing. Here as well we provided the similar thing. The only difference is in the case of human evaluator, we currently are not providing any feedback. If you are building this workflow, maybe you can modify it to provide a feedback as well. In the LLM call evaluator, we are providing the grade along with the feedback produced by the large language model evaluator node. After that, we have a conditional edge. Now again, if you have watched my previous videos, I have explained what a conditional edge is when you are building a workflow in the LangGraph. So if you haven't watched, you can watch my previous videos and try to get an understanding of it. So it basically routes the control flow. So if the joke is funny or not, if the funny or not state has the value of funny, so meaning if the joke is funny, then it will return accepted. If the joke is not funny, then it will return rejected plus feedback. Now this is the conditional edge. I can run this and I can define all the methods here. Now we have building the workflow, or basically now we have a method which will gonna build the workflow. It's very simple. As we used to do in the previous videos, we're gonna define the nodes which we defined above. We declared them here. After that, we declare the edges between the nodes. So this is how the edges look like. First edge is from the start to the LLM call generator because it will gonna generate a joke for us. Then we have a condition. Now this is very interesting. If human in the loop flag is enabled, so the build workflow takes human in the loop flag, which can be false or true, and we can set this true or false when we are building the workflow. So by default, this is false. So if the human in the loop flag is set to true, then we're gonna include the human evaluator node in the edge. If the human in the loop flag is false, then we'll include LLM call evaluator in the workflow, right? So this will gonna create or compile a workflow which will have human in the loop as an evaluator. This portion will gonna compile a workflow which will have a large language model as an evaluator. Very simple. We start the edge with the generator, we give it to the human evaluator. From the human evaluator, we give it to the conditional edge, which returns either accepted or rejected plus feedback. If the output is accepted, then we're gonna end the workflow. If it is rejected plus feedback, then we pass the flow back to the LLM call generator node, and this loop continues. This is also the similar thing. The only difference is we have an LLM call evaluator in place here. And after that, once we have built the workflow, we return the workflow here. So I can also run this. So this is the entire build workflow method. After that, we have to set up the memory and the checkpoint in order to enable the interrupts, and then we can invoke the app. So the first thing we do is that we compile the workflow with the checkpointer and the memory, and then we enable the app with the thread ID. So the thread ID here is 1. We need to have a unique thread ID for a unique run so that we can come back and resume it again. And what I'm trying to do here is I am trying to ask the large language model to produce a joke on the topic nerds, and then I'll try to run it. So for the first time, I'll disable the human in the loop. So what it will do is that it will not involve human in the loop as an evaluator. It will gonna have large language model as an evaluator. So we don't need to interrupt it here, right? And then the model will try to create a joke, and then it will be judged by the evaluator node. So this is how it looks like. If I run this here, okay, so the problem here is that I am not using any interrupt, but still I am accessing for a interrupt key. So what I can do is that I can comment this out, and simply I can print the response here. Because this time we are not using human in the loop, so we don't need to get an interrupt. Okay, so this time is the joke funny, and the LLM evaluator came up with the answer is funny. So the evaluator thinks that the joke is funny, and the joke is, why did the nerd bring a ladder to the bar? Because they heard the drinks were on the house. Okay, cool, interesting. I'm not sure if it is funny or not, but this joke is created by the large language model, and the evaluator thinks that this is funny, so the workflow ended. Now what we can do is that instead of having large language model as an evaluator, we can include human in the loop as an evaluator, and then we can evaluate our joke itself. So if I am here, I don't think this joke is funny, so I would have said not funny, and the large language model would have to reevaluate and create another joke for me. Okay, so now let's try with the another flavor where we will enable the human in the loop in the workflow. And for that, we'll just simply set the human in the loop flag to true, and then we're gonna provide a topic. So this time we are providing the topic as Apple, and let's see what the joke should be. For this time, we can actually comment out the response, and we can directly see the interrupt, because we're gonna interrupt the workflow because the human loop is enabled. So if I run this returns a joke. Why did iPhone go to therapy? Because it couldn't stop comparing itself to all the other models. Okay, cool. So by Apple, I think it is referring to the Apple company, and that's why it is coming up with a joke on iPhone. And this is good. What I can do is that I can say funny, or I cannot say funny, right? If I'll say funny, this workflow will end, but we want to see the evaluator design pattern in practice, so I'll just say not funny. And if I'll say not funny, and I can invoke this by sending out this command, and since we are using the same config ID with the same thread, it will gonna understand which workflow to trigger. So this workflow is binded with the thread ID of 1, and I'm using the same config. It will know that it has to resume the workflow which is currently interrupted, right? So we are sending the command, and we'll see that the large language model will try to generate another joke for us. Okay, I think that it is okay. Why did the iPhone go to therapy? Because it couldn't stop comparing itself to all other models. Cool. I said not funny. Then the joke is, why did iPhone go to therapy? Because it couldn't stop comparing itself to all other smart devices. So the joke is very similar. It's just change here, saying instead of all the other model, it says all the other smart devices. And then maybe I can again say not funny, and this will be bound to okay. Now again there is something, but because it couldn't stop comparing itself to all other smart devices with some emojis. Alright. Maybe I can try again and let's see what happens. Okay, now it says, why did Apple go to therapy? Because it couldn't stop comparing itself to other fruit. Okay, so you see, like, the content is changing, but I don't think the model is performing too well because we are using a very I think we are using GPT-4. Yeah, we are using GPT-4 mini, so I'm not sure it is performing that well to come up with a joke, but you get the idea that how you can keep re-executing the workflow till you think that it is up to the mark. So if I think that because it couldn't this particular joke is funny, I can return funny and this workflow will gonna end finally. Now this workflow ends with a full response saying that joke, why did Apple go to therapy? Because it couldn't stop comparing itself with other fruit. Feedback is empty, funny or not, we say funny. So that's why the workflow has ended here. Now, this is a very interesting structure of workflow where you can, or basically this is a very interesting development of workflow where you can change the structure on the basis of a flag. So we have two flavors of workflow incorporated in a single source code, or basically in a single method where you can change the structure of a workflow depending upon the flag. So if I enable this human in the loop flag, the human in the loop node will be put in the workflow. If it is false, then the LLM node will be put in the workflow, and we can see that, and we can see this in action actually, right? So currently we have enabled human in the loop to true. So if I will draw this workflow here or display this workflow here, this is how it will look like. From the start, it goes to the LLM call generator, and after that there is a human evaluator here because we have enabled the human in the loop flag. So the human evaluator is here, which will decide whether to reject with a feedback or to accept. And the LLM call evaluator, you will see this particular node, although this is declared and defined, but it is not the part of the workflow. So it is placed on the right side, orphan, not a part of any workflow, just sitting idle. Now I can change this structure, right? If I basically change this flag to false and I reconstruct the workflow, although this will fail probably because we are looking for an interrupt. So let's return a response here. So this will now pass with a particular joke, but okay, this time a feedback was also provided. Cool. And okay, this time there is different joke here. Okay, the joke is, why did Apple stop in the middle of the road? Because it ran out of juice. Cool. Okay, there is some feedback also provided by the model saying the joke is lighthearted and playful, using a clever play on words with juice. So now this time it is actually referring Apple to be a fruit instead of the company. So this is okay. Now the whole idea is that we have switched off the human in the loop. So here LLM is actually evaluating, and if we'll display the workflow again, the structure will change here. So this time we have LLM call evaluator as a part of the workflow, which will be basically rejecting with a feedback or accepting the output produced by the generator. And this time the human evaluator node is sitting idle on the right side. And this is how you can basically create an Evaluator-Optimizer workflow, both with the human in the loop flavor or with a language model evaluator flavor. So this was it in the Evaluator-Optimizer design pattern. We discussed what the Evaluator-Optimizer pattern is. We also did a code walkthrough where we implemented two flavors of this workflow, one where the evaluator is a large language model and another where an evaluator is a human. So we discussed human in the loop, or how we can break or interrupt the workflow in between, provide our feedback and resume the workflow from that particular point, right? One more thing I would like to point out is this paper which talks about Agentic RAG, right? Or basically a survey on Agentic RAG. This talks about this particular design pattern as well. So if you are interested, you can read this full paper. It's quite big paper, and I would specifically focus on page number 14 here. So there are a lot of design pattern where it talks here, and you'll see that a lot of design pattern is already covered in my AI Engineering 101 workflow. For example, prompt chaining, routing as well. This is also covered, and along with that, this as well, orchestrator worker design pattern. This is also covered in my playlist. If you'll see the previous videos, you'll find these design pattern videos as well. And this is the one which we are currently talking about, which is Evaluator-Optimizer, refining output through iteration. So you can read onto it, and this is very similar to what we have explained here in this video, right? And yeah, that's it. This was it on the Evaluator-Optimizer design pattern, and I'll meet you in the next video.